By way of example, I want to show you two other things that will come up quite often as you're solving quadratic, or not solving, but graphing quadratic functions. So I have a new function, f of x equals x plus 3 squared plus 1. So I want to determine and go through my same process to get an idea of what does that graph look like. So the first thing I'm asking myself, does the graph open up or does it open down? So I look at my a, in this case, not even written, so it's an understood 1 and it's an understood positive 1. So I know that this graph opens up. The second thing I want to look at is its vertex. And this is where it's tricky sometimes a little bit, because we would look at this and we would think that our vertex is the point 3 and 1, because in the h spot there is a 3. But we need to be careful here, because our standard form of the equation doesn't have a positive h, it begins with a negative h. So I have to have it in that same form. So that would look like x minus a minus 3 squared plus 1. So once I get that quadratic in its exact standard form, not a near copy of it, but exact standard form, which means I have to have an x minus that value of h. And so x plus 3 is the same thing as x take away a negative 3. And now that I can see that its h corresponding value is negative 3, so I have a vertex of negative 3 and 1. Not positive 3 and 1. So really wrap your head around that so you don't make that mistake as you're trying to graph some of these functions. Next, we're going to look at its x-intercepts. Where does this graph equal 0 at? Or where does this function equal 0 at? So likewise, let's solve it by any means that you want. Take the square root of both sides. I get x plus 3 equals the square root of negative 1, or x plus 3 equals the negative of the square root of negative 1. Negative 1, the square root of negative 1 is I, so I have x plus 3 equals I. X plus 3 equals negative I. Get x by itself. I have x equals negative 3 plus I. And then over here I have x equals negative 3 minus I. So both of my x-intercepts are imaginary. And in this particular case, this tells me that I have no x-intercepts. This graph does not cross the x-axis at all. And that's useful information. Lastly, I want to look at its y-intercepts. So let's evaluate this function at 0. F of 0 equals 0 plus 3 squared plus 1. 3 squared is 9 plus 1 equals 10. So I have a y-intercept at the point 0 and 10. Again, there's no x-intercepts. My vertex is at negative 3 and 1, and the graph opens upwards. So let's see if we have enough information to make a very good plot of this graph. Vertex is at negative 3 and 1, so backwards at 3 and up 1. It tells me that the graph opens upwards. There are no x-intercepts. Well, it makes sense. If the vertex is above the x-axis and the graph opens upwards, well, yeah, there won't be any x-intercepts. And then it crosses the y-axis at 0 and 10. And it's symmetrical on both sides. And so there are the key points of that graph that I know. I have a vertex at negative 3 and 1. Graph opens upwards. It's symmetric about this axis. And it crosses right here at 0 and 10. So this problem, this particular example brought up two issues. One, identifying the correct h of the vertex. And you do that by putting it in exact standard form, not near standard form. And the other part is your x-intercepts. Sometimes you're going to get intercepts that cross the x-axis twice. Sometimes once, it just touches it, or sometimes not at all.